Welcome to Lesson 9. In this lesson, kids are going to transform linear equations. So the first activity is going to be move the monster, and they will click here to access a Desmos graph of a piecewise equation, and it simply is going to be moving sliders and observing the behavior of the graph. So as they slide the H to the left and to the right, they should notice that the graph is moving in a horizontal way, left to right. And as they slide the K up and down, the graph moves up and down as they slide K left and right. So notice the numbers, and this is basically their first introduction to translating in the plane. Now they've had y equals mx plus b in 8th grade, so they kind of already know that that b value translates the graph up and down, but we're going to take it a step further and show that it works for all types of functions, including one like this. Now on the slide, I do ask for specific values of h and k for them to use, so they will use -1 for h and +3 for k. So one thing they can do is just type over it. If they're tired of trying to slide it like that, just type over it, and then they need to describe what happened, and then they will export and insert the graph. So they'll click on this little arrow here and click on export image, and then they'll put that in here. If you want to get the little grid lines to show up, you'll need to do a large or a medium rectangle, and then it'll show it. It doesn't matter though. At this point, I'm fine if they don't do that. The next slide is basically the same thing. They're going back to the same graph, this time to let h be 4 and k be -1, and so they'll insert this one. But when they get to the next slide, I'm intentionally trying to make everybody's graph different, because I want each student to, instead of just using their teammates' answers, which you know that happens, I want them to have a unique answer, or as much as possible. So what I've asked them to do on this slide, this is slide 4, and then we're going to let the K, we'll play the K. So we'll press play button, and then just as soon as it gets moving, just hit stop at some point, and then they'll have a value of K. I want them to use that value of K and then describe what that value of K is and how did it transform the graph. For this one, they do the same in reverse. They let K be 0 and click play next to H and then just stop it. What's the new value? What did it do? And then the last one is pretty much the same thing, except they're doing both. So we would go ahead and press play on H and K and let it just go crazy, and they always think that's fun, and then they stop it. Now what's nice about this activity is they can use these slides where they randomly chose a value of h and k for their portfolio, because it is a unique, something they did themselves that's unlike their classmates. So it's something they could add to their portfolio if this is something they want to add. So the next activity is linear transformations, and this is a Desmos activity. So here we have linear transformations, and all we're doing in this assignment is transforming linear equations. We will extend this to other types of functions very soon, but for now, they're going to take the parent, y equals x, and they're going to transform the parent by translating it right, left, up, and down. And you may wonder, what in the world? We don't normally do horizontal translations on lines, but because you'll see how I'm treating this. I treat this linear function just like every other function. So instead of teaching them something different for lines, which we do sometimes, we're going to stick with this same form for all functions, and that way they have an underlying principle that works across the board. Now the kids have already done y equals mx plus b extensively in their 8th grade class, so the kids are going to go to that. That's going to be their go-to because that's what they're comfortable with, and it does take a while to convince them to use this form for equations of lines, but students do come around when they notice that it's more intuitive and they don't have to spend a lot of time looking for a y-intercept to write an equation. You have to not try to push them and be a little patient, because they are accustomed to slope-intercept. They think that's the way all lines are supposed to be written. So this is kind of a new idea for them. All right, let's take a look at the activity. The first screen is going to introduce them to the parent function. Every linear function that exists can be created by transforming this one. And so we're going to do that in this lesson. I'm asking them to complete a table of solutions. And if they don't remember, remind them they can click and drag along this graph to get these points. So -2 is at -2. If you want your y to be -1, well, your x is going to have to be -1 also. And so they will fill this out, and then they will write an equation of a line. Hopefully some kid in your class knows this equation, and if not, you may have to tell them, but hopefully we can get this out of the kids. So the goal in all assignments is to get students to recall what they've learned in prior classes. So I have a lot of teacher moves down here. One is to restrict our pacing, to restrict to this slide so you can have a conversation about the linear parent function. Students can also write f of x equals x. I doubt they will, but that is another form. And I would share out a correct student answer if at all possible. Something you might want to point out or get the kids to notice is that this equation, or this table, the x column looks exactly like the y column, and that's not a coincidence. That is what it means. Y is equal to x. And then you can have a discussion about the word parent function. Why do you think it's called that? Why does the equation y equals x work? And so forth. I would keep kids on this slide until most of the kids or all the kids are done, because this needs to be done before they discuss the next part. The next slide, we're now transforming by changing the slope. I do use this delta y over delta x form every time I discuss slope, and we review delta y over delta x means change in y divided by change in x. I do not use rise over run. I do not use y2 minus y1 over x2 minus x1. I pretty much just use this through the course, as you will see. Most kids know this one because this is your classic y equals mx plus b. So they'll say y equals x plus 2. And they're pretty good at this one. And then they'll explain. Now, if they don't know what they're doing, I did include the graphing calculator button here. They can type in y equals x plus 2 and make sure they got it. Just in case, because you know some of them have slept since last year and they forgot things, and we need to bring it back, and we want to bring it back in a way that they don't forget it next summer. This is something they should hang on to probably a lifetime, because some of these are basic concepts that they'll use in every lesson. And then here's where what I do is different. And really there's no other assignment out there. I would have used someone else's, but nobody does this. I've always done it. I did it before I even believed in inquiry as a method, but I use it because it's a universal concept that applies across the board to all types of functions. So what I have included here is, do you notice that when you translate a line up 2 units, you're also translating it left 2 units? If the slope is 1, like it is here. And that's because both a translation up is always a translation left for a line. And so what I've told them to do to keep track, we're going to use parentheses anytime we go left and right with a translation. So I've given them a starter in the blank, and I just want them to take that 0 out and replace it with a number. So notice the fine print here. We are going to draw a third line that is translating the parent right 2 units. So I'm going to choose the green here, and I'm going to choose the line tool, and we're going to translate this right. So we're going to start at this 2. The slope is 1. And then we're going to complete the equation. So we're going to do x minus 2 to translate it right 2. Now, using the calculator button, they will probably want to type this in. They will notice they don't really need the parentheses, and you will have kids say, well, that is a y-intercept of -2, so why isn't that just y equals mx plus b? Well, for now it is, but in a few minutes it won't be, because we're going to change the slope, and we're also going to use a vertical translation as well. So we're building at this point, and they will probably they'll tell you they don't need the parentheses. And they're right. They don't at this point. But we will, I just let it go and I move on and show them in the next few slides why those parentheses actually do matter. So let them know it serves a purpose, and we're going to see that very soon on the next screen. So when they get to the next screen, we're going to translate both right 3 and up 2. So you'll notice the form I'm giving them. Well, to go right, we're going to use the parentheses, and to go up, we're going to put the number outside like we always do. So this will translate the line right 3 and up 2. Now, unfortunately, I don't have a way of adding that to that graph. So if they want to check their answer, they can just type it in just like that in here, and then they can click on the line and show that this does go through the 3, 2. There it is, 3, 2. So that is the correct answer, and then they would submit. I do ask them to draw the new line, so they definitely want to use the line tool, and they want to go up 1, right 1, so it needs to be right in here. Let's do this. Looks pretty good. So right in there, it's kind of got a bump in it right there, but that's good enough. So I do ask them to sketch these, and that's translating twice. Now we're going to put it all together. We're going to put a slope in here of a half, and we're going to say translate right 2 down 1. So if the slope is a half, we know this is a half in front, and then we're going to translate it right 2. Well, that's actually minus 2, and then we're going to translate it down 1. So this is not plus 0, but minus 1 or plus negative 1. And they'll ask, and they write it that way, and you're like, yes. Minus 1 and plus negative 1 are the same thing, so both are good at this point. I do ask them to draw the line and put in a new slope triangle, so let's do it. We're going to draw a line. And then we want a slope triangle. So I would use some other color to differentiate between my lines. So maybe that orange again. Draw with a pen. 2. So to use delta y and delta x, I always like to do that. I'm going to pick a different color. I'll go with blue. So this one's delta x. And this is delta y. And they have to draw them this way with a pen. We don't really have another tool, unfortunately, to make them nice in here. Some kids will figure it out, though. I've had kids go out on the web and find these and paste them as text in here, and I love it. I love when kids are resourceful and come up with ways to type things. But that's a slope triangle. And then you're going to submit, and then they'll answer some questions. So they would say the slope was the 1/2, so you're multiplying by a half. You're moving it right 2, so you subtract 2 from x, or whatever they need to say. And then, so here is a card sort. They have 4 sets of 3 cards, and each set will have a graph, a description, and an equation. They can do it however they want. I would probably start with a description, but I wouldn't tell them that. And once they get those sorted, they will be finished with their Desmos activity. The next one is a fun activity, and it doesn't take as long as you think. I had a block schedule when I did this activity, and I've done it with Algebra 2 and Algebra 1, I think. And I've had, it went really quickly in one of the classes because they're pretty smart about figuring out a way to do this. But let me show you what it looks like. This is from Math Equals Love, and it's called Tongue Twister Linear Regression Activity. And basically they're going to be given a sheet, a data sheet that looks something like this, and they are going to fill out these tables and create linear regression equations in the Desmos calculator for these tables once they're full. To save on time a little bit, I told them to only do 7 rows of the table. There's actually 9 rows, I think. So they don't need 9. 7's plenty. But if you want to do 9, you can. You could do 8. You could do whatever you want. But they're going to say these tongue twisters, and then they're going to come over here to their slides. And then once they've completed their table for A, they will create a linear regression equation. Now, I did give them some instructions, and these instructions are in the show notes for the students in their slides. So they would need to read these. You could probably go over it with them. But basically, they're going to pick up a data sheet like the one I showed you. You can download that directly from Math Equals Love. It's a PDF, and print those off and give everybody a copy of a data sheet. And then they will work together in teams. So first they will speak the tongue twister on their own and time it. And they can work together in their team to each do that. Maybe have another person help them out by timing it while they're reading it. And then they'll do it in teams of 2, 3, 4, 5, 6, and 7. So they have to work outside their teams. Our teams are only 3 or 4 kids in my class, so they would have to combine with 2 or 3 other teams to get this done. So kids are up and moving about. It's crazy. It's loud. They're laughing. But every time I've done it, they've really enjoyed themselves. So it's kind of a break, a true brain break, but they're still learning at the same time. They need to not start over. That's kind of the only rule they have. If you mess up, the timer needs to keep running when you go back to the beginning. And don't worry about the time. We kind of want the times to do crazy things. It makes the data more interesting. So they will want to start the timer over. Just tell them don't do that. Stay right where you are, let that timer run, and then go to the beginning and say it again until you can get to all the way to the end without a mistake. And then they'll record the time. They are recording the time in seconds. So most timers have minutes and seconds. So you might have to remind them that there's 60 seconds in 1 minute in case they forget that. But they're going to go ahead and get this one done. Once A's done, they've got all 1 through 7 done. They need to sit down. That's when they need to do some math. They're going to create in Desmos a table, a graph, and an equation. Now, I am still giving them links out like to Desmos, but eventually these links are going away because they're going to be able to just go on their own, Desmos.com, and get a calculator and do this. But for now, I'm giving them a link out. There's very little in here. All I did was give them a teams 1 through 7. If you decide they need to do 8 or 9, they can add extra rows to this table. They just click down here and put an 8 and then a 9 if you want to do all the rows. And then they'll put their data here in seconds. And then they will click the little plus sign. There will be a little zoom fit hourglass here on the bottom left of their table that will fit their data. They should come in here and label this. It's not labeled. And they should put words in here, not just X and Y. Well, what is X? X was the number of people on the team. And then Y, well, that was the time in seconds. So they should label these. They can adjust this as much as they'd like. But they do need to create the graph, and then they're going to do a linear regression equation. I'm not going to do this one for you because I've done these many times, but it's y1 tilde mx1 plus b, which of course is not going to work because I don't have anything in y1. But when they type that, it will create a linear regression equation, and it will graph the line over the data. And then they will take a picture of that, and they will take a picture of their table and their equation, and they will put all of that on this slide. And then they're going to answer one question: what does this slope reveal about the tongue twister? And so hopefully they know that the more teammates there are, it changes up or down. I'm not going to tell you. It may be not what you think. I think it did something I didn't expect when they did this. And it happened every year. So eventually I started believing maybe my thinking was wrong on this one. But they will put that in here, and then they will type in that space what that number means in this context. And then they'll repeat this for B. It's a different tongue twister, and C and D. Now, to save on time, if you want to cut out one of the tongue twisters and just do 3 of them, or maybe choose 2 of them, that's fine. But they're still going to have to get them all done, all of the same one done to fill out the table. And then finally, the last slide with the tongue twister is to tell which slope was greatest and what does that reveal. Of course, if you did all of them, if you didn't do all of them, this may be a harder question to answer. It may be greatest of the ones you did. What does this reveal? And then they're going to choose one of the regression equations they created to make a prediction for the entire school. So you will probably have to tell them the population of your school. You could include faculty too if you wanted to. And then they need to tell which tongue twister they chose, A, B, C, D, and then determine how would they have determined the amount of time for the whole school. And hopefully they know to plug into their equation to make that prediction. So now we should be into day 2. You may not be able to finish your tongue twister linear regression activity in one day. It may have to spill over into day 2, or for some of you, if you're not on a block schedule, day 3 even. But the last 2 are not as long, or shouldn't be. The next one is a slope estimation activity in a Desmos activity. So this next activity is actually an open middle task, and so I'm going to click here to go straight to it. You will have this linked in your guide. But this is slope estimation with marble slides. And I have used this both with my 8th grade mathematics as a slope assignment, and I've also used it in Algebra 1 as basically a review. And so these are great fun. So they're going to drag these numbers into here. So they're looking here, and you see they don't even have a grid. So they're just estimating the slope from the graph. So rise over run is what a lot of them are going to say, but I always say change in y. Let's say this is 2. This might be 3. I don't really know. That looks pretty good. And then this moves the line up and down, positive to negative. And then that's too low. Oh no, we can move this up. Yeah, you can drag this around. I think this might actually work. Almost. 3 and 4. But you see what I'm doing? I'm guessing and checking. That's what we expect them to do. But we can also talk about the fact that this line is going over to the right more than it's going up. So we know this change in X, and use that language when you're doing this, and you can do it with them, and show them multiple student answers, because you can get this right. A lot of these, there are multiple correct answers, but the goal is to get it to say success. And as once it says success, they're done. They don't have to do it anymore. And so all of these are the same. And let's review. This changes this from a positive slope to a negative slope. So if they need a line to go down, which is this one's down, they'll need to move that down. And this moves the line up and down, which they can't see a line until they put something in here. But let's do 1. Let's do 1/8. And that's not going to work, but you get the idea. So it's decreasing 1 and it goes right 8. Change in y over change in x. So the last activity is connect the emojis, and this is kind of a summative assignment, because if they can do this, they can do all the rest. And I would say this is a great one to let them just play with for a while before you step in and give them too much help, and I'll show you what I mean. Okay, we're still in the slides. This is your last slide, and I definitely would do this last. You can rearrange most of the rest, no problem. But they need to have access to that slope activity. They need that first. They also need to know how to translate left, right, up, down. That's important. So be sure they do that before they get here, because they'll use all those skills in this assignment. So here we are in the connect the emojis task, and you'll see the emojis for this first one are the castle, taco, avocado, and a house. So they're going to go from here to this taco, to the right to the avocado, and up to the house, and the goal is to connect those with line segments. So I've started the process for them, and they're just going to finish it by putting in numbers for the question marks. But if they don't know what they're doing, they will mess it up in a hurry. So you may tell them, if you make too big a mess, just go back to the slides and click on that and go back to a clean graph and start over, because that's likely to happen in this task. So the first point is -3.8. That's where the castle is. And it went to -2.5. So I'm going to click and hold this one. I don't know why that one won't stay, but it doesn't. So notice the x value was -3, and then the x value was -2. So that's telling me my domain went from -3 to -2. And then it's also, I've got to do the slope. So let's click on this one again. This slope went down and right. Well, how far down, how far right? Well, it went from 8 to 5, so it went down 3, and it went right 1. So the slope is -3. So we're going to put that here in the front, and notice how it connected that with a line segment. They can pull this over if it cuts it off, and it might. So tell them they can do that if they need to. And then they'll continue. So for the next piece, it says y is equal to something, and it goes from -2 to +4. This one you can see it. I don't know why that castle's like that. It's the only one that's like that. But we're going to go ahead and put the number 5 for this one. And then the domain goes from x equals -2 to x equals +4. So that one's correct, and it does connect it with the red line. I do have kids that say, I want them to all be the same color. So if they do want that, they can click here and change this to match the other one, or they can choose some other color. And then finally, the last piece goes from the avocado to the house. So I'm going to click here. I'm going to click here. Yeah, this one's not sticking either, doesn't look like. Yeah, that one doesn't stick either. All right, so I know that the slope is 3, and that was already on there. From 5 to 8 is 3, and from 4 to 5 is 1, so 3 divided by 1 is 3. I need it to go right something and up 5. Well, that's the avocado, so I'm going to say right 4 up 5 and use the 0.45. And then I've already got the domain from 4 to 5, so let's see. Let's change our question mark to 4, and that should be all you got to do on this one. And that connected the dots. Now once they finish a folder, see these all little lines are here, they click on this triangle to close that one, and then they start on the next one. So you may want to do these together on the first one. If you can get kids to do these, like let them work a while before you do any of that, let them do it. If you can find a kid to get these all 3 right, I'd have volunteers do each piece. If you can't, and this is a challenging task for kids at this point. It's a lot of skill in here. If you can't, then it's okay if you have to show them. But as always, anything you can get the kids to show is better if they do it. Not only will that kid remember it better, but the other kids are more likely to actually listen to that kid than to you. So try that way first. One thing I do want to point out is notice these little gray lines are showing that this is in this folder, so they can close the folder, and they can also turn off the folder and it will erase those segments. They will want to turn those back on when they take their final picture, but for now they can turn those off so that they don't get in the way of any of the other parts. And when they're finished, turn all their folders back on to take a picture and insert on their slide. So that concludes our transformations moving functions activity. I did schedule this for 2 to 3 days. This is another foundational assignment. It's worth it. It's fun. I mean, there's some fun things to do in here, but they're big, important things. So I tried to make it as painless as possible. Not as much real-world application in this case. We're just doing the math underneath the application, but we will be applying these ideas soon in assignments. If y'all have any questions or comments, let me know. Have a great day.